Ideal Systems are here working with Now TV and working with PCCW to produce the 360 VR experience that people will be able to watch through Oculus headsets, Samsung Gear headsets, and also on tablets and mobile devices, or on a PC with a mouse to be able to move around in 3D. Marcus, can you tell us a little bit about the camera, what the lenses are, what sort of resolution, and how you get that amount of data out of such a little cable?
Happy to answer that. So what you're looking at is our Nokia Ozo camera. So we have 8 lenses on here that you can see, and I'd like to point out there's not just lenses, there's also small microphones placed around the camera. So there's also 8 microphones. So not only do we capture 360-degree 3D image, but we also capture 3-dimensional sound, which is also very important and important to point out. So out of these sensors, so each of these lenses has a 2K by 2K image. We compress that signal through this fiber cable back here. It's actually using something called an SFP adapter, which is an industry standard. We're getting the 2K by 2K in a raw signal, so it's Bayer pattern, so it means it's in a raw format. It's getting packaged into this fiber line right here and getting decoded on a live stitching server on the other side. So right here, what you mostly see when you connect directly would be just noise because it's raw data. And that's actually the way we are managing to get all this information into this one cable, is by keeping the raw data and keeping the raw Bayer pattern while we are sending it to the stitcher.
Can you run us from where it goes from here, and what the workflow is, and from your experience, how different is it from previous legacy production world that you're accustomed to? Anakin.
Thank you, Fintan. So what the Ozo does, it basically is an 8-camera output, and it starts with a traditional IP output. We go into the broadcast world and then go back into the IP world. But with the Nokia Ozo, it just simplifies the entire workflow, because one output from one fiber cable is an IP output of 8 cameras. And those 8 cameras, I don't have to synchronize, I don't have to time them, I don't have to do anything. I go straight from one cable right back to my control station. And in there, it goes into the live server. The live server takes all those 8 cameras, stitches it, and gives me a 4K broadcast output, a 4K quad output. When I have 3 cameras with 4K output, then I take them to a switcher. I mix those 4 cameras, 3 cameras, 4 cameras, it could be 8 cameras. And then again, I encode the mix output back to encoding servers, which again takes back the same switched output of 3 cameras or multiple cameras with metadata into the servers. The servers then send this output back to whichever is your CDNs, and the CDNs will further transfer to your Samsung devices, viewing devices, or it could be an Oculus Rift or HTC Vive.
Fenton. What we do is we take the output in 4K from the vision switcher and we pass it through to 2 harmonic encoders, and out of that we're creating 7 outstreams at the moment for the rugby. We're doing a dash stream at 4K, a dash stream at multi-resolution from HD down. That is used for the heads-up display visors, which Vincent will now model for you. Also, we're creating a number of HLS feeds as well, one in 4K, one in multi-rate. That is used for web properties, so our client will take it out and put it on their website. Further to that, we're also sending RTMP streams out to Facebook and to YouTube as well, so they'll have YouTube Live. Coupled with that also, for YouTube publishing, we appear on the 360 channel in Google Cardboard. So the platforms we're dealing with are the Oculus products. So it's the Gear VR from Samsung. We're also servicing the Vive from HTC. They're the 4K platforms. Underneath that, we've got the website outputs from our client to run on their Navigator property. They're doing sit down at your PC and scroll around type VR. What we have here also is 2 publishing servers, so there's 2 ways of delivering to the CDNs. We're doing push to a number of CDNs, so we basically publish on 2 publishing servers that are put together by us, and then there's a number of CDNs coming in and picking up from our file system and then republishing on the CDN. Also for YouTube and Facebook, we actually push straight from the encoders through via RTMP through the firewalls, so we also provide the network security. And the backhaul to the internet is done via 2 fibre 1 gig links, so we have main and backup, main and backup. Everything is dual path and redundant. We're basically publishing a couple of versions of this program in different resolutions to a CDN, which is then used for the main distribution for the 4K and the subsequent, the lower resolution as well. And that's dash streaming as well. So we're doing dash, we're doing HLS, we're doing RTMP, all out of one process on the harmonic encoder, and then we distribute it through the various publishing platforms.
So PCW Global is expanding its media delivery capabilities, and part of that we see VR as a big future in media delivery. Our specialty is in the network delivery and connectivity, and we believe that bandwidth is going to be a huge part of delivering live VR. So PCW Global has partnered up with Ideal Systems to deliver this source-to-screen VR project. Ideal Systems has provided all the VR production skills and expertise, while PCW Global has contributed on the connectivity and media delivery. Together, that brings a source-to-screen solution for the Hong Kong Sevens.